Now let's take a look at some network appliances. There are a few here that we will talk about, such as jump servers, proxies, IPS, firewalls, and more. First, jump servers. What is a jump server? This is a computer that is used to manage access to a different security zone. So you use a jump server to get into a security zone. Imagine here, this is an external user connecting to a private network. He can use a jump server. It can be a server. It can be a laptop. It can be any different kind of computer that gives him access to a private network. So we call that a jump server. Jump server allows users to access internal devices through a connection on the single device, and it creates like a layer of security between the user and the destination. First, you connect to the jump server, then you jump to the connected systems, as you saw on the illustration. The next is a proxy server. A proxy server is a server that acts as an intermediary. It forwards requests from clients to other servers and vice versa. I like to show this illustration where this guy, for example, he goes to Chick-fil-A and he makes an order like, "Hi, can I get a grilled chicken sandwich with a lemonade?" That's my favorite Chick-fil-A order. And the the person is like, "Here you go," and everything, the process takes about 15 minutes. Now, the next time he goes to Chick-fil-A to make the same order as usual, it's like, "Hey, boss, same thing as usual." And the server is like, "I got you." And the server is like, "I got you." And he gets his order. And the next time it takes about 4 minutes. So that's a little bit how a proxy works. It's like it remembers users and their requests and it forwards the request. So instead of directly connecting you to a website, you connect to the proxy and the proxy connects to the website for you. And proxies are used for security filters to block access to certain websites or block content. And proxies also do caching. So it remembers what you did before and it can reconnect you to a website or to a communication that you previously did. So proxies are like intermediary servers. And you have, for example, this user here in the home network. First, he connects to the proxy and the proxy connects and reloads and sends him the page if he had already accessed CNN.com. If he had never accessed CNN.com, first it will go to the CNN.com before sending him the web page. But the next time he connects, it will directly fetch from the proxy. So that's a little bit how a proxy works. It remembers communication and resends the communication to users. Then you have sensors. Sensors monitor network traffic and collect data for analyzing and alerting. So you can have a sensor almost everywhere within the network. It monitors the traffic, on the level of traffic, on the type of data, on the amount of users, on the different sources of IP addresses and more. And depending on what you want to do, you can collect the data for analysis and to create alerts. Another type of network appliance is a load balancer. What is a load balancer? This is a tool that distributes network traffic across multiple servers so that one server is not overloaded. Now, to better understand load balancers, it's important to see this acronym and we'll make sense out of it. So imagine that you are this steakhouse and you are working at a steakhouse. Now, this steakhouse has only one server. But how many customers? So many customers and only one server. So they are all angry and they all have different kinds of problems. This one needs help. This one is their food. This one is still hungry. No one is served and they don't understand. They need help. Now imagine this other steakhouse with multiple servers. So you have multiple customers at the table, each of them taken care with the server. Everything is perfect. The service is excellent. They are all satisfied. So what happens at the end? One will have a 1-star rating and the other one will have a 5-star rating. In a nutshell, that's how a load balancer works. So a load balancer improves performance by preventing any one server in a system or in a network by being overloaded. So it's a way to improve the performance and reliability of applications. Imagine that you were the developer of Instagram application and that you had only one server in your data center, but then you had millions of users all around the world. Your servers will be overheated, they will always crash, and your application will not work. Now imagine that you have 500,000 servers, and that around the world, every 100 user is connected to one server, for example. Your application will flow very fast, will be very responsive, and if there is a crash, another server will easily take over. So that's the difference between, that's how a load balancer works. So here's an example with the Facebook, for example, and they have multiple servers. For the illustration, we will only show 4, but suppose they have multiple servers, like hundreds of thousands. And now you have users from around the world who connect, and they are not all sent to the same server. So one at a time, they are sent to a different server in a kind of round robin scheduling. Each person is sent to a new server as they connect to the other server, and it keeps going. So that's a load balancer. That's how it works. It balances the load by making sure that each user or each server is evenly used. The next security network tool is an intrusion prevention and intrusion detection system. So important acronyms: IPS, IDS. IDS and IPS watch the network traffic and they take actions based on events. First, you have IPS. IPS, the P stands for prevention. So intrusion prevention systems. It prevents an attack before it reaches a target. It prevents, so it blocks. Meanwhile, IDS does not actively block, but it detects and it alerts, but it doesn't block the attack. IPS, intrusion prevention system, blocks an attack. IDS detects and alerts about the attack. Now, under IPS and IDS, you have two other types. You have host-based IPS and host-based IDS. These are on single systems. So these are on a computer, on a server. They are installed as a software on an individual system. So in a network, you can have 100 computers and all 100 of them can have an HIDS and an HIPS, host-based intrusion detection system, and host-based intrusion prevention system. And similarly, you have network-based IDS, IPS, NIDS, and IPS. This monitors activity on an entire network. You have network-based IPS and network-based IDS. So just to show an analogy on what we said, the IDS in this case, detection system, will be like a security guard monitoring traffic. And the IPS is like a security guard actively blocking. And this is how you can look at it as well. So you have an internal network here, and you have Jeff who is trying to connect to the network. There is a firewall, there is an IDS, there is an IPS, and all that lead to the network. Now, the first one, so when Jeff tries to send malware into the network, the IDS, so the detection system, cannot block the malware, but it will alert. So it will raise an alert that there is something in the network. Meanwhile, the IPS prevention system actively blocks the malware. So it prevents the malware from entering the network. A couple more network security tools. First, you have 802.1x. This is used to protect Wi-Fi and internal networks. And this is a protocol that is used to authenticate devices before they are allowed access into a network. So you have probably already authenticated into a Wi-Fi before entering your username and password at a school campus, for example. That is a system behind that called 802.1x. So it authenticates devices before they access a network. EAP, Extensible Authentication Protocol, provides a method for systems to authenticate as well. And there are different types of EAP authentication. EAP prevents access to the network until authentication is successful. So as long as you have not authenticated, you will not be able to access the network. And it can also be used to create other forms of authentication. So first, let's take a look at 802.1x. Here you have multiple clients who, before accessing an internal network, they have to log in with a username and a password, and they get access to an authentication server. Now, how does EAP work? You have a few different types of EAP. You have one called EAP TLS. For example, you have Marlene here who is trying to log into cybermook.com. First, what happens is her computer sends a certificate. Remember domain one, what a certificate is, used to prove your digital identity. The computer sends a certificate to identify itself. And cybermook.com server will also send a certificate to identify itself. So there's like a mutual authentication between Marlene's computer and CyberMook's server or any other website. Here you have another example. Steve, who is trying to log in, the server will send a certificate to authenticate itself, and then an encrypted tunnel will be created for Steve to connect to the system. This is PEAP. So the first one was EAP TLS. The second one is protected EAP, PEAP, protected EAP, because it's protected by TLS tunnel. This one is EAP TLS.
All right, guys, that concludes our course for today. Let me know what you think. Hope you enjoyed it. And make sure to follow us on all our social media platforms, which includes YouTube, Instagram, Facebook, and TikTok. Of course, do not forget to order our awesome Amazon flashcards that you can get for just $15, and they're awesome because they help you study.